So up to this point, we already know there exists an optimal level of the saving rate that will be able to allow us to maximize the consumption. And we do have a name for this saving rate, which is called the golden rule saving rate. So how to come up with this golden rule saving rate from the Solow diagram as long as from the equations? That's what we are going to show as follows. So to begin with, let's try to get the golden rule saving rate from a Solow diagram. Remember that when we draw a Solow diagram, we have the vertical axis represents the output per capita. The value on the graph can also represent the investment per capita. On the horizontal axis, we draw the capital stock per capita. Because given each level of the capital stock per capita, we will be able to come up with the output per capita, investment per capita, and consumption per capita. So as you may recall from what we already learned, when we draw the Solow diagram, we will need to draw the output curve, which is the output equal AK to the power of theta. We also have the steady state condition, which tell us if we want to stay at a certain level of the K, what should be the investment required to stay there. So then the last line that we need to draw in here is that once we are given a saving rate, then we will be able to know that the savings need to be equal the investment. And then so the saving curve represents the size of the actual investment. When the actual size of the investment equal to the investment indicated by the steady state condition, then we know the intersection of these two lines is the capital stock in the steady state. And then from here we will know because the saving equal the investment, and then we know the level of the output given the K steady state, we know the size highlighted in red is the size of the consumption. So this is under a set of the Solow model, which is given the saving rate as 1. When we are given another level of the saving rate, which is S2 tilde, and then we are going to get another saving curve, and then so we are going to have another size of the actual investment, and then the intersection of this actual investment and the steady state condition, which is telling us the investment required to keep at the same level of the K, then that will be the K steady state. So then when we are looking at another Solow model given another saving rate S2 tilde, and then we are going to get another capital stock in the steady state, that is K2 steady state. And then for this particular level of the capital stock in the steady state, we are going to be able to get another consumption in the steady state, which is highlighted in purple. Finally, if we are given another saving rate, that is S tilde 3, and then we will be able to draw another saving curve given that in equilibrium saving equal investment, and this is the size of the actual investment. As long as the size of the actual investment equal the investment required to stay at the same level of K, then we will be able to pin down the capital stock in the steady state. And then we also know that the line highlighted in orange will be the corresponding consumption in the steady state when we are having a model given the saving rate as 3 tilde. So then based on this diagram that's highlighted in the curve that is related to the production function, and the other line that we want to highlight is the steady state condition. So then we know the consumption is the distance between the production function and the steady state condition given any level of the capital stock in the steady state. So now let's zoom into these two lines in detail. So then how to come up with the consumption that is maximized, which means that we want to find where the distance is the largest between the production function and the steady state condition. It may not be that easy to look at this particular graph, but then when we push this graph downward and then have the green line horizontal, then you will say, hey, from this graph, I know if I want to find the top of the hill, we know that as long as the distance of the orange line and the horizontal line is the highest, then we will be able to identify the highest point of the hill. And then we say, hey, wait a minute. What we know is that the solid line and the dashed line, in fact, is the triangles. And then we know that for different triangles, as long as they have the 90-degree angles, and then as long as the other angles are exactly the same, then we know that the lengths of each side of the triangle, in fact, are proportional. Due to the property of the triangles, we know that as long as the dashed line is the longest, then the solid line also needs to be the longest. Because of that, we know to find out the top of the hill, we can find a line that parallel to the horizontal line, and then we will be able to find the top of the hill. So then we can push this diagram back to the previous one, and then we can add in the dashed lines. After we add in the dashed line, we know that when we want to find the consumption that is maximized, we need to find a line that parallel to the green line, which is in blue. So what is the characteristic of this blue line? So then we can put this blue line back to the Solow diagram we had earlier. And then we will notice that for this particular line, it has to tangent on the production function, while it needs to be parallel to the steady state condition. So then what we know is that in order to find the saving rate that maximizes the consumption for a Solow model, we need to draw a line that is tangent at the production function, which is parallel to the steady state condition. So in here, you can clearly see that when we are given a saving rate that is S2 tilde, when we are going to get a capital star in the steady state, that will give us the consumption that is maximized. So this is the way to come up with the golden rule saving rate under the Solow model. So to summarize the discussion up to this point, we say that if we want to find a saving rate that allows the Solow model to maximize the consumption, we need to find out the slope of the steady state condition. Under the setup of our current model, the steady state condition tells us that the investment required to stay at certain level of k need to be equal n plus delta kt. Therefore, the slope of this steady state condition is n plus delta. So to find the consumption that is maximized, we need to find a line parallel to the steady state condition, and this line needs to tangent at the production function. And what we know is that for any line that tangent on the production function, it is the marginal product of the capital. Therefore, we say that to find the point where maximize the consumption is that we find a line that tangent on the production function. At the same time, it needs to be parallel to the slope of the steady state condition. So given that for any line that tangent on the production function indicates the marginal product of the capital at any given level of the k, so then to have a Solow model that have the consumption is maximized, we need to have a saving rate. It turned out to have a property that is, given that saving rate, it is going to get a steady state capital star in a steady state. And that particular capital star at a steady state need to have its marginal product of the capital equal to n plus delta. And then that particular saving rate is the saving rate maximize the consumption, and that is the golden rule saving rate. So that is how to come up with the golden rule saving rate from the Solow diagram. Then how to come up with the golden rule saving rate from equations.